Hello, I'm Craig. Let's talk more about cars. So I left off with shocks and struts and springs. We're moving on now from the suspension system. Let's start talking a little bit about the steering. You can see it right in this area right here. We're moving on. So steering, basically we have two different types of systems or designs. Our modern systems, rack and pinion steering, allow us low weight, good feedback to driver, minimal wear parts, can be manual or hydraulic. We'll show you a picture in a little bit, don't worry. The other system or design, conventional steering gearbox. Heavy duty design can be manual or hydraulic. Again, I'll show you some pictures of these systems so you know what I mean. So here's a system that's basically the newer rack and pinion design, the steering gear. You pull up some labels, and I'm going to work my way from the center out basically. So if you have, in here it's kind of hard to see, but your steering intermediate shaft comes down from your steering wheel, the steering column, and as you turn that, it's going to turn a shaft right here. That comes in and turns a gear in here, and that runs this whole rack left and right inside this housing. Okay, so we have this housing that's bolted to this cross member right here, and inside that housing you have pistons and rams and gears that move left and right as you turn this part here, the steering wheel. Again, it gets way more complicated than this, and they all have specific names, but we're going to go into that in a different class. This is an introduction to overall theory. Okay, so as I move that steering wheel and rotate that shaft inside this rack housing, basically these pistons are moved. This inner tie rod on both sides, and the inner tie rod end is hard to see because it's in these bellows boot, and those boot is designed to keep dirt and moisture out of that inner tie rod end, because that inner tie rod end goes down into the seals and the pistons. You don't want to get dirt and water in there because that can cause corrosion and damage and leakage. So again, that inner tie rod end moves left and right according to the steering wheel. It's connected to the outer tie rod end. If you look over here, the outer tie rod end, which is connected to the steering knuckle right there. And of course, this jam nut is what allows us to adjust the distance between this knuckle, this outer tie rod end, and the inner tie rod end. And that allows us to change alignment angles. We will talk about that in a little bit, specifically the toe. Okay, so again, this is kind of a modern system. It's lightweight, it's small, not as rugged as a conventional steering gearbox, but very useful. You'll see this in cars, and light pickup trucks. Very common. And we'll talk more about some other suspension stuff. Let's look at the conventional gearbox. So in this system right here, you got this big Ford suspension, rugged, of course, because it's a Ford, you do that. And you got a conventional gearbox right here. So again, you can't see the input coming from the steering wheel, but I want to show you the pictures at the bottom. When you turn this gearbox, this Saginaw recirculating ball gearbox, when you turn that steering wheel and that input to this box, it's going to turn this arm right here, which is a pitman arm. And then that's going to turn and move this linkage right here. That's connected all the way down to this knuckle. And then you have one over here connected to this knuckle. And there is different types of systems how the conventional gearbox works, especially the linkage types. But this one right here has all the parts that we need to talk about today. So here's some important stuff. Sway bar. Again, we'll talk more about that later. But sway bar's job is basically, as you can tell from this one side picture, this big, like torsion bar almost, looks like a big torsion piece of metal. It goes through this bushing, which is mounted to the frame, comes down over here, and it's going to go to this sway bar link right here. And then that sway bar link is going to connect it down to this lower control arm. And basically the sway bar is going to help provide handling characteristics to the car and to keep it from rolling. Sometimes they're called an anti-roll bar, anti-sway bar. There's different names for them. But what effectively happens, it's kind of hard to explain. Again, there's going to be a video at the bottom of this to show you in animation how a sway bar works. But what's going to happen is as you dip, this side comes down, which means this control arm right here is going to effectively go up. As this car dips down, it pushes up on one end, which pushes down on the other. So as you're rolling, like to the left, let's say your body is rolling to the left, the sway bar is going to push down on the right. Okay, it's going to push up on the left and down on the right, trying to get you to kind of straighten back up. Because it's kind of shaped like a U, it wants to stay that shape. So as you roll, it's going to twist and it's going to want to go back to straight. Okay, again, I'll show you a video which will explain that a lot better. There's your pitman arm. That's what comes out of the gearbox that actually turns all the steering linkages. Here's your center link, which is what the tie rod ends are connected to here. And of course, you have your inner tie rod end and your outer tie rod end. and there's your knuckle, right? So this is what pivots the brakes, the hub, the wheel, the tire, all that is connected to the knuckle. And the knuckle in this case is connected to the upper ball joint right here. And that's what allows it to pivot to that upper control arm. And then the lower ball joint right here. This is the knuckle right here. You can see this whole assembly. And that's what turns and pivots on these points, the upper ball joint and the lower ball joint. Okay. There's your upper control arm and lower control arm. And then the tie rod sleeve, again, just like in the rack and pinion, this allows us to adjust toe and alignment angles, which we're going to talk about in a little bit. So basically that is all the steering components for the SLA, short arm, long arm. Here's your control arms, and it's also the conventional gearbox style steering suspension. Okay, so all these joints right here, you see all these joints, tie rod end, inner tie rod end, ball joint, all these joints can wear, and there's going to be play in that. And that's something that the technician is going to have to learn how to recognize play and find out which parts are worn and replaced. And they all need to be lubed. So you'll see right here is a little Zerk fitting right there and right there. There's one on top, there's one right there, there's probably one on the other side right there. And that allows you to use a grease gun. You put it on that Zerk fitting, pump the handle, grease goes into this boot inside that joint, and that's going to allow for that to operate better. And again, if you don't want to over grease that, you don't want the grease coming out of that boot, you want the boot to remain intact, and this boot keeps, again, moisture and dirt stuff out of the joint, prolonging life. You'll learn more about that in the chassis class in the program. All right, so that's steering. Well, all of this stuff, like I mentioned before, has got to be adjusted, like this sleeve right here, for different alignment angles. And why do we want them adjustable? Well, do you want a car that goes down the road crooked? Do you want to have to constantly fight left or right with the steering wheel to go straight? Do you want it to handle decent? Do you want your tires to wear out fast? No, probably not. And you do want it to handle good and all these things, so we have what's called a four-wheel alignment. So all suspension components must be tight. The vehicle should be normally loaded. Tire pressure and size correct. All four wheels should be aligned to OE specification. So if you drive around a car or a truck and you have lots of stuff in the trunk anyway, I would put that load in there. You'd want to have good tires, the right pressure, the right size. Again, you want everything to be tight and in good working order so that the technician, like right here, he's got it hooked up to this system, this little Hunter system. It's going to monitor with these lasers and these little pads right here to see how straight this vehicle's suspension and steering is. And that allows us to ride down the road, again, straight. So a couple different things that, different angles we can look at. But again, you want to make sure that whatever load you have is going to be right. You want to make sure, tire pressures are good, because all this can affect the alignment. Okay. You also want to check your ride height, which again is this kind of this, if it's squatted or diving in the front, you want to make sure this is all even. If you got a saggy spring, that's also going to affect the alignment angle. So yeah, ride height is basically, like this, right? Make sure it's normal. Yeah, this is highly modified, right? That would be really difficult to align. So moving on. Different kind of alignment angles. Okay, so we have different angles, which we'll talk about here in a minute, but the purpose of, again, the alignment is for directional stability, cruising on the road, to be straight, reduce tire wear, cornering, returnability. So when you go around a corner, you want the wheels to go back to straight. That's part of the alignment. Predictability, so you can kind of understand what it's going to be like going in a corner at 60 miles an hour. Tracking, so your car, again, goes straight down the road. Road isolation, feedback, you can feel all that in the road. You don't want to be soggy and spongy and disconnected. And you want the steering wheel to be centered. All of that is alignment angles. So the most important alignment angles, camber, right? So camber is measured in degrees from true vertical. As you can see right here, here's a picture of the car. So the tire is perfectly square and straight and vertical. Anything that's going to be positive, it's going to tilt out. That's a positive camber. And then negative is when it tilts inward. Okay. So if you look at this camber, basically if it's off, you're going to have certain kinds of wear. If it's positive, right, you're going to have this outer edge wear because it's leaning out like this picture. If it's negative, it'll lean in. You're going to have that inside wear. So this is something you can look at when you're purchasing a car. Take a look at the tires. You can tell a lot by the tires. We'll talk more about that on Thursday or the next lesson. But basically that's camber in a nutshell. Typical degrees, you're going to see negative 3/4 of a degree. I've seen some cars negative 1 degree. They're not going to be zero. You want them slightly leaning in for that stability and that predictive kind of handling. So here's a picture of severe, extreme negative camber. Yeah, I'm moving on. So caster is measured in degrees from true vertical using the steering axis. This is the axis which the wheels steer. Right here you'll see this McPherson strut, and it pivots on this red line. So the wheel turns on this red line, this red pivot. If I run this spring strut assembly back further, that red line is going to be diagonal, right? Which means the wheel will turn in an arching, overarching kind of pattern. That's caster. So if that center's back, that's positive. And if that center, that steering axis center is forward, that's negative. Okay, so that's caster. Now this isn't a tire wearing angle, but this is something that will help with drivability, okay, handling. It can cause pull if it's off, but basically, again, it's not a wearing angle. It's just something that, think of like on a shopping cart, right? Those wheels, they're castered in a way that they're going to automatically track straight. So kind of the same thing on a car in a real basic analogy, okay? Toe, this is one of the fastest wearing tire angles, and this is what's shown in this picture, is a difference in the distance measured between the lines drawn right here, these yellow lines, through the center of tires of the same axle. So front and rear of the tires, they basically, the distance between this part and that part need to be the same as this part and that part for a zero toe. Okay, we don't run zero toe, we run a different, here we have typical toe reading, 16th to a 32nd. Again, the total toe is combined toe on all that. So if you take a look at toe in is positive, right? That gives a little bit of stability, toe out negative, okay? So if you look right here, we can be anywhere from a positive 16th to a negative 32nd, depending on the vehicle. Okay, it all depends on driver preference too, really. But yeah, you got a little toe in or toe out. Okay, too much, and you're going to scrub all these treads off because you're dragging the tires sideways. The more toe in or out you are, you're effectively, as you go straight, you're dragging the tire tread sideways. And you're going to see that. You're going to see that in the tires if you're looking at a used car. Again, if it's wore on just the one side, that's camber. If it's dragged out, that can be an alignment angle as well, like toe. And we'll talk more in depth about this next lesson. We'll talk about tires and wheels and more wear angles on that. But whoops, right here. Okay, so tire rotation, I'm going to basically leave you on this because, again, next lesson we're going to talk more about tires. People have asked me what's the best rotation method for tires, and I'm going to tell them basically I have my opinion of what I like to do, but as long as you're consistent, that's more important, and make sure the car can handle that rotation. What I mean by that is not all cars can handle what's called cross to drive, like these pictures right here. These are cross to drive rotations, which are my personal favorite. So a rear wheel drive vehicle, right? They're back here, right? This is what drives the vehicle. So those twisting tires, we move them straight forward to let the belts inside relax. And then when they're in the front, we cross them to the other side, cross to drive, okay? Now, if you look at the front wheel drive, since the fronts are the ones driving, we bring those straight back to let those relax. Again, we'll elaborate more on that on the next lesson when we talk about tires. But we bring those straight back to let the steel belts inside relax because they've been twisting the whole car, twisting while they're pulling the car down the road. And then when they're in the back and relaxed, the rear gets crossed to drive. We cross them. And that's going to allow for, if you have abnormalities on one of these angles, these alignment angles on any of these positions, it's going to spread that wear among four tires, prolonging your tire life. And that's the idea of rotation. And most people do this every other oil change. Again, if you have directional tires, they can't be swapped left to right. They have to go front to back. And some cars have what's called staggered, which means the front's smaller than the rear. And directional, you can't rotate them. It is what it is. When one tire wears, let's say the left starts wearing drastically, that's it. You just got to let it wear, replace the whole set. That can get expensive. And that's why we rotate tires. We're prolonging that wear and basically saving our pocketbook. But again, we're going to talk more about that next week. So stay tuned underneath this video. There's going to be a couple more videos explaining like torsional force, that's hard to explain, and how sway bars work. Those two things are hard to explain via PowerPoint, so I linked some videos, and that's it. That's part 2, and I will see you on the next lesson.